Nag-aral ka na ba ng Moment of Inertia? Kung hindi pa, halina at panoorin mo ang tutorial na ito. So parang ewan yung intro natin, no? So anyway guys, welcome to LectureCEries Channel. So for today's video, we're going to discuss about moment of inertia, and specifically we're going to discuss about polar moment of inertia and transfer formula for moment of inertia. So dito po muna tayo guys magfo-focus, and sa mga next video tutorial natin is itatakal naman natin, ang i-discuss naman natin is how to derive formula na ginagamit sa pagsasolve ng moment of inertia, specifically yung ating composite areas, which is yung rectangle, triangle, circle, semicircle, quarter circle, and parabola. So, pero sa next video pa po yun. And also yung mga sample problems will be sa next video pa. So, dito po muna tayo sa ating polar moment of inertia and transfer formula for moment of inertia. So, without further ado, let's start. Okay guys, moment of inertia. So before tayo totally mag-proceed sa moment of inertia sa kanyang theory of structure, sa ating theory of structure, is i-define po muna natin siya sa moment of inertia niya na napag-aralan natin sa ating physics. So ito po guys is kinuha ko po sa isa po sa reference book ko sa aking pag-aaral noong nag-aaral pa ako sa physics. Ito ang Shams Outline College Physics. So, ano ba yung moment of inertia niya sa physics? So, hindi ko na po ito masyadong babasahin, pero tingnan na lang po natin yung kanyang equation. So, I is equals to m1r1 squared plus m2r2 squared plus m3r3 squared and so on, where m is mass and r is a distance, where yung units niya will be kilogram multiply by the square meter. So, paano po siya kinocompute, kinakalculate sa ating physics? So, syempre, i-measure daw natin yung distance r from any particle in the object to the axis of symmetry, and then i-square natin yung distance niya and i-multiply natin yung squared distance din sa kanyang mass particle until ma-repeat natin yung every particle and i-add natin yung mga values niya. So, paano ba natin siya guys i-relate sa ating theory of structure? So, sa ating theory of structure, the moment of inertia about the x-axis and y-axis is the summation of the product of each differential area by the square of its moment arm. So, this gives, So, this gives, ito po yung ating equation. When it comes sa ating theory of structure, Ix is equals to integration of y squared dA and Iy is equals to integration of x squared dA. So, dito guys, magmumula yung ating formula na ginagamit sa ating moment of inertia. So, yung moment of inertia ng ating rectangle, triangle, circle, parabola, quarter circle, semicircle, diba? So, from this equation guys, dito natin siya matiderive, which is yun yung ating ipo-proof later on sa ating mga next video. So, saan ba to guys natin maaalalang pinag-aralan? So, pinag-aralan po natin siya sa ating integral calculus. Yung sa application guys ng ating integral calculus wherein kumukuha tayo ng strip, diba? And then na-apply natin yung integral natin. So, under siya sa moment of inertia sa ating integral calculus, diba? And then, syempre guys, yung units niya will be different. Kasi nga, diba, sa ating physics, minumultiply yung square distance sa kanyang mass of the particle. So, therefore, yung units niya will be kilogram multiplied by the square meter. And then, dito naman, since nag-integrate tayo, so, diba, yung integration nitong y squared is y cubed over 3. And then, yung differential area natin will be, kunyari, base times dy. So, diba yung unit ng base natin is millimeter, ganon. So, millimeter times mm raised to 3 will be mm raised to 4. So, yung units niya guys will be somehow different. So, yun nga guys, sa ating theory of structure, kumukuha tayo ng 3 for in differential area natin, kaya tayo nag-a-apply ng integral calculus natin. So, okay, so paano po ba tayo nag-come up sa ganitong formula? So, bago ang lahat, ang aking pong reference book na ginamit is ang Strength of Materials by Ferdinand Sr. and Andrew Pittel. So, nasa party po na padulo yung topic na moment of inertia. So, ang moment of inertia po is tinatawag ding second moment of area. Why? Because pares lang naman po siya ng pagkaka-define dito. So, babasahin lang po ko lang po. So, a differential area is multiplied by its moment arms that gives the moment of area, and when multiplied a second time by its moment arm, it gives the moment of inertia. Kaya po tinawag din siyang second moment of area. So, meron po tayo x and y axis, meron tayong differential area, meron tayong moment arm. So, distance x from y axis and distance y naman from x axis. So, pag mag-moment of inertia tayo about sa x-axis, so ix is equals to integration of y squared dA moment arm y squared dA sa kanyang x-axis. And then naman, moment of inertia about the y-axis naman is iy is equals to x squared dA. Okay? So, let's now talk about polar moment of inertia. So, ano naman yung polar moment of inertia? So, ang polar moment of inertia naman guys is yung moment arm naman niya is with respect sa kanyang origin. So, ang kanyang definition is the polar moment of inertia about the axis through point O perpendicular to the plane of area is defined by, so meron po ulit tayo x and y axis, meron tayong differential area, and meron tayong moment arm na x and y, and meron po tayong moment arm mula sa kanyang origin hanggang sa kanyang differential area na isaset natin as a variable r. And then, applying lang po ulit yung natutunan natin about moment of inertia. So, J is equals to integration of the square of our moment arm times sa kanyang differential area. And then, what is r squared? So, from Pythagorean theorem, guys, r squared is equals to x squared plus y squared. So, isa-substitute lang natin siya, guys, dito. So, magiging x squared plus y squared times dA. Then, distribute. So, magiging x squared dA, which is ix, at saka y squared dA naman, which is, kung ma-recall natin siya, is iy. And then, ang unit natin is mm raised to 4. And then, how about the transfer formula for moment of inertia? So, ginagamit naman to guys kapag ayaw na natin mag-integrate ng panibago. Halimbawa, nakuha na natin yung moment of inertia sa ix, diba? Pwede ka din kasi sa iy o kaya moment of inertia sa centroidal axis. So, kung nakuha na natin yung kahit isa sa kanila, makukuha na natin yung kung ano man yung isa pang kailangan. So, halimbawa, meron tayong ix, tapos kailangan natin kunin yung centroidal axis. So, pwedeng gamitin na lang natin yung transfer formula for moment of inertia. So, the transfer formula is a method applicable even without doing further integration. So again, meron tayong x and y axis, meron tayong differential area, and then kapag kukunin natin yung kung kailangan natin makuha yung moment of inertia with respect to centroidal axis, so magsaset lang tayo dito as moment arm y, and then dito as d, and then moment of inertia with respect sa ating x-axis guys is y plus d, yun yung kanyang moment arm, squared dA. And then, i-expand lang po natin. So, magiging y squared dA plus 2dy dA plus d squared dA. And then, kung mapapansin nyo guys, ito na-cancel na, naging 0. Bakit? Kasi guys, yung ano natin is square ng distance. So, kung mapapansin natin guys, dy siya. So, hindi siya pumasok dun sa square ng distance natin. Kung sana naging y plus d squared siya, which is ito, hindi naman. So, naging dy siya. So, meaning, nag-0 na lang yung ating moment arm natin dyan. So, tuloy lang po natin. So, kanopya ka lang po ito dito. And then, ito naman guys, d squared constant. So, integration po, recall lang ang ating integration. So, integration ng differential area natin is a. And then, kung matatandaan natin na itong part na to is Ix, but siya po is with respect sa kanyang centroidal axis. Since yung moment arm po natin from differential area na y ay hanggang sa centroidal axis natin. Kaya naging Ix plus AD squared. Tapos, ito naman guys is with respect naman sa x-axis since ito po yung ating ginamit, which is y plus v squared, okay? So guys, ito yung sinasabi ko na kailangan na magagamit natin yung transfer formula for moment of inertia. Halimbawa, nakuha natin yung value ni moment of inertia with respect sa x-axis. Pwede na natin ma-solve yung moment of inertia with respect sa kanyang centroidal axis. Isa-substitute lang po kasi natin yun dito. Or kahit itong centroidal axis meron tayong value, pwede natin makuha itong moment of inertia with respect sa x-axis. So, same lang din po siya sa kanyang y-axis. And then, meron po tayong radius of gyration. And through this figure, guys, meron tayong I is equals to integration ng k squared dA. And then, constant po si k, kaya k squared na lang. And then, ang integration po ng ating differential area is a. And then, iano lang po natin, yung a po ilalagay natin dito. So, magiging I over a. And then, square root both side. Kaya magiging k na lang to at naka-square po to. Kaya naging k is equal sa square root of I over a. So, ang unit niya po is mm. Since nga yung I natin is naka-mm raised to 4 at ang area po natin is naka-mm squared. So, magiging square root of mm squared na lang and magiging siyang mm na lang yung unit niya. Okay? So, guys, dito ko na po muna tatapusin ng aking tutorial. Sana po meron po kayong natutunan and pasensya na po kung medyo binibilisan ko and sana po hindi po ako nakapag-waste ng oras nyo and sana po pinanood nyo po siya mula umpisa hanggang dulo. So, our next tutorial will be the derivation of moment of inertia, yung mga formula ng rectangle, triangle, circle, semicircle, quarter, circle, and parabola. So, tigi-isang video tutorial po siya. So, isang video tutorial sa pagde-derive ng moment of inertia ng rectangle, and so on and so forth. So, bago ko po tuloy ang i-end yung video ko, please subscribe to my YouTube channel and follow my Facebook page. And bigyan ko lang po kayo ng konting yan po yung sunod kong mga ituturo, okay? So, thank you guys for watching. I really do hope that you learned something from me, and thank you and God bless.